we'll be discussing about qualitative analysis in this lecture. Qualitative analysis of ions is the detection of the presence of anions and cations in samples of water, mixtures of salts, etc. It is used in analyzing water samples for the presence of impurities, checking for adulteration in the sample of oils, cereals and pulses. Whenever a sample has to be checked for the presence of any impurity of metal ions which can be poisonous, there is a systematic scheme which needs to be followed for the detection of salts of metal ions. This analysis has to be done on a semi-micro scale. The analysis of a mixture for cations and anions is done on a semi-micro scale in the laboratory, since we need to detect only the presence or absence of a cation or an anion and not determine its quantity, in contrast to volumetric titrations. Like we see in the case of volumetric titrations, we have to analyze the quantity or the amount of a particular ion or a cation in the sample. However, in case of qualitative analysis, or as we say salt analysis or mixture analysis, we are detecting only the presence of the anions. Hence, even small quantities of the mixture can be analyzed and they are taken for analysis, as it reduces the wastage and also reduces pollution as the reaction mixtures are thrown in the basin. The advantages of using a semi-micro analysis is that this kind of analysis is more economical and less time consuming. There are various types of analysis which can be used to detect anions and cations in a mixture. So apart from semi-micro analysis, different type of other analysis methods which are followed include the macro analysis, the micro analysis and ultra micro analysis. Macro analysis uses large quantities of samples for analysis, which is tedious and polluting for the environment. As the name suggests, macro means large. Micro and ultra micro analysis are fast techniques like chromatography and spectrophotometry. Chromatography, which is used for the detection of ions by various methods like TLC, paper chromatography and so on, and spectrophotometry, which is used to detect ions by the way of colored solutions to be put in a spectrophotometer. Semi-micro analysis involves the same scheme of analysis as the macro one, but on a smaller scale. Hence, the scheme of analysis depends only on the quantities of the mixture sample taken. These are some of the apparatus which are used in the semi-micro analysis, wherein semi-micro test tubes are used, which are much smaller than the normal test tubes. The normal test tubes which are used in the laboratories are of 10 ml. These test tubes are much smaller, maybe of 2 to 3 ml, and other apparatus which are used, as you can see from the figure, are also on a much smaller scale. In contrast to macro analysis, where filtration is used to separate a precipitate from the solution, in semi-micro analysis, centrifugation is used as a means of separation of a residue from the solution. So centrifugation has its various advantages. In semi-micro analysis, filter paper is not used, but precipitates obtained are separated from the solution in a centrifuge machine, and this is how a centrifuge machine looks like, the outer area and the inner picture. Centrifugation is a quick process in comparison to filtration, where we can consider the advantages of centrifugation. The precipitate gets localized at the bottom of the centrifuge machine and can be easily separated from the solution by decantation, which is not in the case for precipitation or filtration in a normal scale. Even the washing of the precipitates can be carried out easily on a semi-micro scale in case of centrifugation of the precipitate. Now, in a normal mixture analysis where we analyze cations and anions in the laboratory, H2S gas, or as we can say hydrogen sulfide gas, is used for the detection of cations. It has to be first prepared in the lab, and it is prepared in the KIPS apparatus, which picture as you can see on the slide on the screen, by the action of concentrated sulfuric acid on the sticks of ferrous sulfide. So there are 3 bulbs in the KIPS apparatus, and in the central bulb FES or ferrous sulfide sticks are put in, and the sulfuric acid, concentrated sulfuric acid, is poured from the top of the apparatus, and it gets in contact with ferrous sulfide to release H2S gas, and which can be used for the detection of cations which are precipitated as their sulfides. Now, when we talk about the mixture analysis, there is a systematic analysis followed for the detection of a mixture containing various cations and anions. And in this case, first of all, anions are detected, and then the analysis for cations continues. So the test for anions is done in a systematic manner. The anion detection in a mixture is done by dividing the anions into 3 groups. The first group includes the dilute sulfuric acid group. The second one is a concentrated sulfuric acid group, and third one where the anions which are not covered by any of the above groups are considered. For the detection of anions, certain preliminary tests are to be carried out which tell us the indication of the anions which may be present in a particular sample. These tests, which are also called dry tests, involve the detection of anions with the dry mixture. These are not conclusive tests, but they give a good amount of information of the presence of ions. The color of the mixture is also very important as a preliminary test which can give an indication of the anions which are present in the mixture. So by observing the color of the mixture, it gives an idea of the colored ions which can be present in the mixture. For example, if the color of the mixture is green, then it may indicate the presence of nickel ions or ferrous ion salts. Preliminary tests also include the flame test, in which the color of the flame when the mixture paste is inserted in the flame can tell about the cation present. For example, if a paste of the mixture is prepared in concentrated HCl, taken onto a platinum wire and immersed in the flame, then if the color of the flame is apple green, that may indicate the presence of barium ions in the mixture. Although this flame test needs to be carried out systematically in cation analysis later on. So considering the test for anions, the acid radicals or anions can be detected in the mixture by the following tests. As described earlier, the first one is the dilute sulfuric acid group. In this case, to 10 mg of the mixture in a semi-micro test tube, which is given as SMT, 2 ml of dilute sulfuric acid is added and it is heated slightly on a stone block. Stone block is an alternative to the flame or a wire gauze as in case of a semi-micro analysis. And after this, the observations are noted for the above test. If a colorless, odorless gas evolves with a brisk effervescence, an effervescence just like the one in which when we open a bottle of cola, that kind of an effervescence which turns lime water milky, indicates the presence of carbonate ions in the mixture. And as you can see on the slide, on the picture, the color of the lime water turning milky once the gas which is involving turns lime water milky. If in case reddish brown fumes evolve which turn potassium iodide starch paper black, that means a paper dipped in a solution of potassium iodide and starch is put on the mouth of a test tube from which the gas is being evolved, and that paper turns black in color, that indicates rather the presence of nitrite ions in the mixture, and the brown fumes which are evolved are seen as in the picture by the side. If in case mixture on the treatment with dilute sulfuric acid and then heating evolves a colorless gas with a rotten egg smell, which turns lead acetate paper black, then it indicates the presence of sulfide ions in the mixture. These are all indicatory tests. They are yet not confirming the presence of the anions. If in case a colorless gas evolves with a burning sulfur smell which turns the dichromate, potassium dichromate paper green, this indicates the presence of sulfite ions in the mixture. As you can see in the picture adjoining, the original color of potassium dichromate is orange. On coming in contact with the gas if evolved, it turns green. Then it indicates that sulfite ions might be present in the mixture. Then there are certain ions, for example acetate and ammonium. Acetate is an anion, ammonium is a cation. These ions have to be tested in the very beginning. The tests for acetate and ammonium are to be performed at the beginning of mixture analysis because these two anions can be detected by their smell tests only. So as we proceed on with the analysis, there are so many fumes in the laboratory wherein it becomes difficult to identify these ions later because the number of smells are there due to number of reactions being carried out, and hence acetate and ammonium ion need to be detected by their smell test in the very beginning of mixture analysis. So in the test for ammonium ion, the way to perform it, to 0.5 milligram of the mixture which is taken in a semi-micro test tube, 1 ml of NaOH solution is added. If an ammonia-like smell is observed, then it confirms the presence of ammonium cation in the mixture. The reaction for ammonium with NaOH is given wherein ammonia gas is being released, which is giving the smell of ammonia. Apart from this, another confirmatory test for ammonium which can be given is the Nessler's reagent test. The above gas, that is ammonia gas, which is being evolved, is passed through Nessler's reagent, and if reddish brown precipitate in the test tube are observed which contain the Nessler's reagent, it confirms the presence of ammonium ions in the mixture. And this is the equation, the chemistry involved in the test for ammonium cations in a mixture. The Nessler's reagent K2HgI4 on reacting with ammonium ions produce brown precipitates which have the following composition. And as you can see by the adjoining picture, this is the color of the reddish brown precipitate of the Nessler's reagent, which confirms the presence of ammonium ions in the mixture. Then for the test of acetate ion, a pinch of the mixture is taken on a watch glass and a pinch of oxalic acid is added to it. This is then moistened with a few drops of water, rubbed and smelled. If a vinegar-like smell is obtained, then it confirms the presence of acetate ions in the mixture. And the equation or the chemistry involved follows. Acetate ions on reacting with oxalic acid give acetic acid and oxalate ions along with it. And acetic acid is the one which is giving the vinegar-like smell and confirms the presence of acetate ions. So since ammonium ions and acetate ions both are detected by their smell test, so therefore they have to be performed at the very beginning of the analysis. Moving on to the test for anions in the concentrated sulfuric acid group, wherein the mixture is taken in a semi-micro test tube and 2 ml of concentrated sulfuric acid is added to it, and the semi-micro test tube is then heated, and after that various observations are noted. In case there is a colorless pungent smelling gas, a toxic smelling gas which gives white fumes, when a glass rod dipped in ammonia is placed over the mouth of the semi-micro test tube, it indicates the presence of chloride ions in the mixture. So those colorless pungent smelling gases which are coming out are due to chlorine gas, or as we say HCl, which in coming in contact with ammonia forms ammonium chloride, which gives white fumes or a white deposit on the glass rod. The second observation, if in case reddish brown fumes are obtained, it indicates the presence of bromide ions in the mixture, and that is due to the evolution of bromine gas. This is the chemistry involved. For chlorine, chloride ions are reacting with sulfuric acid to release HCl, and HCl is further reacting with ammonia or ammonium hydroxide to give ammonium chloride, and this is the one which gives white fumes on the glass rod. And for bromide, bromide is reacting with sulfuric acid again to produce HBr, and further bromine, which is producing brown fumes. In the third observation, if violet fumes are seen on the action of concentrated sulfuric acid and the mixture, it indicates the presence of iodide ions in the mixture. Fourthly, if brown fumes which intensify on the addition of copper turnings are observed, it indicates the presence of nitrate ions in the mixture. Brown fumes are observed both for bromide as well as for nitrate, but the difference between the two is that in case of nitrate, these brown fumes will intensify if to the test tube, semi-micro test tube containing the mixture and concentrated sulfuric acid, some copper turnings are added and the micro test tube is heated. If the fumes in that case intensify or increase in quantity, then it will indicate nitrate. Next, if the oily droplets are observed on the sides of the semi-micro test tube and the gas evolved gives a white deposit on a moistened glass rod which is put on the mouth of the test tube while the gas is being evolved, it indicates fluoride ions in the mixture. The chemistry involved for iodide, as in reaction with sulfuric acid, is forming HI, and further iodine, which is giving violet vapors. For nitrate, is reacting with sulfuric acid, NO3 minus is reacting with sulfuric acid to produce NO2 or nitrogen dioxide gas, which is giving the reddish brown fumes. And upon action of copper turnings, the fumes are intensifying or increasing in quantity. And for fluoride, F minus is reacting with H2SO4, which is sulfuric acid, to give HF, and further fluorine, which is giving oily droplets on the walls of the semi-micro test tube. Now, up till here we have discussed about the detection of ions in the dry test, as in the dry test or directly with the mixture. Now, tests for anions can also be performed in the solution, and these tests are generally considered as confirmatory tests for the anions. So, if the mixture is soluble in water, then the water extract can be used for the detection of ions. However, if the mixture is insoluble in water, then the solution of anions is to be made in the sodium carbonate salt, or as we call the soda extract or sodium carbonate extract. Since the sodium salts of all the anions are soluble in water, so there is a need for the preparation of the soda extract so that the ions can be brought into the solution and they can be detected easily, because detection of ions generally depends upon dissociation of a salt into its respective ions, which is possible only in solution form. When we consider the formation of a soda extract, then we first, in detection of the analysis of the ions, the soda extract needs to be prepared, and the method of preparation of soda extract is around 300 milligram of the mixture is taken in a semi-micro beaker, which is again a part of the semi-micro apparatus, and to this 300 milligram of a solid sodium carbonate is added to it. That means equal amount of the mixture and sodium carbonate are to be used. After that, 5 ml of distilled water is added to this above salt, and the solution is boiled for about 5 minutes. After this, the solution is filtered and the extract obtained is called the soda extract. The residue is discarded and the solution is further used, which is called the soda extract, for the detection of anions, or for the confirmation rather of the anions in the mixture. So coming to the confirmatory tests for anions, which are also performed as wet test as in the soda extract. For carbonate, we have already discussed the preliminary test. Coming to the confirmatory test, 1 ml of the soda extract as prepared above is taken in a semi-micro test tube and 1 ml of dilute sulfuric acid is added to it. This solution is heated and the gas which is evolved is passed through the lime water. Now this test can be performed with the dry mixture as well as with the soda extract. The observation and the inference as we get, if the lime water turns milky, this confirms the presence of carbonate ions in the mixture. The chemistry involved can be said as carbonate ions are reacting with sulfuric acid to produce carbon dioxide gas. This carbon dioxide gas is producing a lot of effervescence in the semi-micro test tube. This gas, if passed through lime water, which is calcium hydroxide, gives milkiness in the lime water due to the formation of calcium carbonate, and this confirms the presence of carbonate ions in the mixture. This is the way as the picture shows, wherein the bubbles or the effervescence is seen in the test tube and the gas which is being evolved, that is a carbon dioxide gas, on passing through lime water is turning lime water milky due to the formation of calcium carbonate. But if this lime water is this milky lime water is further subjected to carbon dioxide, that means the carbon dioxide is passed for a longer time through lime water, then this milkiness disappears because of the formation of soluble bicarbonate ions. And as the chemistry involved goes, the calcium carbonate which is causing milkiness is further reacting with carbon dioxide in excess to form calcium bicarbonate, which is soluble and goes into the solution. Thank you.